Hey folks, spot the 6 scaling mistakes that kill 94% of models. A 2023 databricks survey of over 500 teams found that 94% see no performance gain when scaling beyond 10 GPUs. The bottleneck isn't GPU count, it's the training pipeline. Most engineers blame hardware, but the real issue is how you handle data, gradients, and learning rates. That's the reality check. Let's start with the first three mistakes. Mistake 1, bad batch sizing, too small oscillates, too large overfits. Mistake 2, ignoring data bottlenecks. Your GPU is idle while the CPU struggles. Mistake 3, wrong learning rate schedule. Most teams just guess without testing. These three derail most scaling attempts. Now compare small versus large batch sizes. Small batch gives sharp minima, better generalization. Large batch gives smooth minima, faster, but overfits. The sweet spot is usually 32 to 256, but it varies by architecture. Resonates like smaller batches. Transformers can handle larger, experiment systematically. The key is to test a range and track validation loss. Overfitting to small test sets and poor gradient accumulation both kill generalization. As Andrej Karpathy said, the hardest part of scaling is the data. Data quality determines everything. Noisy data amplifies with more compute. Teams that spend 80% of their time cleaning data see better gains than those who tweak model architectures. This insight is backed by years of experience. Investing in data pipelines pays off more than architectural tweaks. Remember, garbage in, garbage out. Mixed precision training with FP16 can cut training time in half. That's a proven 50% speed up on modern GPUs, yet many teams avoid it due to perceived complexity. With automatic mixed precision in PyTorch and TensorFlow, it's trivial to implement. No excuses. Just add a few lines of code and see immediate benefits. Gradient accumulation versus clipping. Accumulate for memory, clip for stability. Here are the fixes. First, automate data preprocessing. Second, use mixed precision correctly. Third, implement learning rate warm up and cosine decay. Fourth, validate on a large test set. These four fixes transform scaling from a gamble into a science. Apply them consistently, start with one change at a time, and measure impact. Iteration is key. Another quote from Mate Zaharia: scaling is about fixing weak links, not adding GPUs. He's seen hundreds of companies fail because they threw hardware at a software problem. The weak link might be data loading, gradient accumulation, or learning rate. Fix that, and scaling becomes predictable. He co founded Databricks, so he's seen it all. The lesson: identify your pipeline's weakest link and strengthen it first. Teams that fix these issues see up to 5x throughput improvement. For example, a Spotify team reduced training from 2 weeks to 2 days by fixing data bottlenecks and using mixed precision. The key insight: optimization is often simpler than you think. It's not about adding more GPUs, it's about using them efficiently. Start with the basics. Compare naive scaling, add GPUs, increase batch size, keep everything else, versus correct scaling, tune learning rate, fix data loading, use mixed precision, validate. Correct scaling yields faster training, lower loss, and better generalization. It's not harder, it's smarter. Many teams overcomplicate when simplicity works best. Focus on the fundamentals: data, batch size, learning rate, and precision. That's the secret. Key takeaways: start with data quality, tune batch size and learning rate together, use mixed precision, validate on a real test set, iterate systematically. These steps put you ahead of 94% of teams. Apply them, and scaling becomes repeatable. Don't skip any step, they all matter. Consistency is more important than brilliance. You've got this. And that's the story. Subscribe to this channel for stay informed on AI updates. Catch you in the next one.